Well, good morning, everyone, and thank you, Chris. It is a great pleasure for me to be here. So, how do we think about a world where everything is connected to the internet? Let's see, Chris, you probably have a control.
Sorry, yes.
And can we boot up my talk, please? So as the talk is, perfect. As the talk is coming up, let's talk about the concept of connecting everything in the world to the internet. Now, I know there are a lot of experts in this room, but since this is streaming live to a lot of people, I'm going to talk very generically. So let's start by a very simple statement. When you think about everything connected in the internet, you can forget about the sci-fi movies you've been seeing. So the network is not going to become self-aware and challenge humankind for the planet Earth. We are a long, long way from having a computer that will pass a Turing test, which the experts in the room know is the test that Alan Turing generated to say a computer has true human intelligence. The network is not going to act that way. There's experts here from Google, in spite of all the great stuff that we see with voice and the technologies that are developing. We're still a long, long way from having intelligence in our computers, at least what we would call intelligence. Nonetheless, we are in a world that is becoming instrumented at an incredible rate. There's over 1 billion transistors per person on the planet now that's created every year. And over 30 billion RFID tags, tagging everything and allowing them all to get connected. So things are getting instrumented and interconnected. About 1 billion people on the internet today, over 4 billion with cell phones of one form or another. And so we really have a whole set of things, cars, appliances, cameras, you name it, all connected to the internet in one way or another. It is a sea change in how things operate. And the things that are all getting connected are maybe not have human intelligence, but they're very smart. And they're generating enormous amounts of data at an incredible rate. 15 petabytes of new information are being generated basically all the time, and that's much more data. 15 petabytes. A petabyte is 1 million billion bytes of data, and 10 to the 15th. And that's more information than it exists in all the libraries in the U.S. combined. So it's an enormous amount of information available as everything gets instrumented and connected. So we really are in a world where that interconnection of everything is going to change everything, and it's going to change all businesses. And what I'm going to talk about is how this is going to impact business in a particular way. So let me give you some examples. The examples that I've got here are taken from some of IBM's Smarter Planet stuff. You may have seen it on commercials, but just to give you an example of the problems that can potentially be addressed, we waste about 170 billion kilowatt hours each year just because we're not very thoughtful on how we use power. Just wasted. We lose 3.77 billion hours of work and 2.3 billion gallons of gas just in the U.S. alone, and that's wasted, not spent in commuting. That's wasted because the commuting that people do is inefficient. And we have about 100 million people that are thrown into poverty every year because of medical expenses around the world. So there are huge losses, huge problems, of which there are potential solutions when you think about everything being connected. Again, some IBM examples. 10% of the energy in a prototype experiment in Pacific Northwest was saved just by letting consumers have the potential of connecting their appliances to the internet and decide when they go on and off. 20% less traffic. In an example in Stockholm where there was thoughtful use of car tolling and a number of other little innovations. And $80 million saved in healthcare in the University of Pittsburgh Medical Center just for thoughtful, better use of medical records. So those are 3 examples of things that you can start thinking about when the world gets interconnected. And we need it. This is an example, an estimate of where the world population is going to be in the next few years. And even the most conservative UN prediction is that it's going to go from where it is now, 6.5 billion people, to at least 7.5 billion before it starts to decline, and that's being conservative. And it could ramp up from 6.5 up to 14 billion. So we're talking about, needing to have the world we live in be more efficient to deal with this, the ecosystem. And if you talk with companies, CEOs, and you ask them what do they think is going to happen given all this, they all think there are going to be major disruptions in their industry. They think there are going to be major disruptions, and the fact is, more now than ever before, they're not sure they know how to deal with them. Now, an example that really would have hurt me in my old job at IBM, if you ask these CEOs, how in the world are you going to get your innovation, and where are you getting it now? Only 14% of them thought they got it from their R&D. And if my boss, Lou Gerstner and Sam Palmisano, if they thought that I was not giving them their innovation, I would have been out of a job. So where's it coming from and what's going on? If we have, and why is it that our R&D around the world is so inefficient that people think that's not where their innovation is coming from? Notice they think it comes from business partners and employees, much more than they think it comes from the R&D labs. The reason why all this is happening is as we go to an interconnected world where everything is on the internet, the actual fundamental nature of innovation is changing. And Chris touched on it as you think about the evolution of business. And I want to emphasize this in a slightly different way. As a business sector is young, the companies in that sector tend to be vertically integrated. Think about the automotive business when it just started. Ford actually planted rubber trees in Brazil so they would have the best tires. So everything that Ford did, they did vertically integrated to make that car. When IBM made its early PCs that sort of stimulated the growth of the PC business, they made everything in that PC except for the microprocessor. They didn't make the microprocessor because they owned 20% of Intel at the time, and they thought Intel was going to go under. And so they wanted to boost up Intel, and they let them do the microprocessor. And we don't always have a good view of the future, even with an R&D lab. Nonetheless, they made everything. When we got out of the PC business a couple years ago, what did IBM make? Nothing. They didn't make the screens, they didn't make the disk drives, they didn't make any of the componentry they went into. They assembled, they tested. Actually, IBM didn't really assemble or test either. It was done by third party. And they distributed. So as the industry matured, you went from vertically integrated companies to those that operated in an extended value net, where the componentry was integrated and success became distribution. That's how industries mature. Now, I want you to think about this picture of an extended value net and think about that as every component of what a company does. Everything that a company does can be thought of as a business component or a piece of hardware that was assembled one way or another to provide an output. So think of a company as a collection of services-oriented pieces of software or components. Those components, these little building blocks, can be added, changed, moved around. They can be received from other services suppliers. And that's really what happens when an industry matures, because what happens when it's young, profits are good, there isn't a lot of competition, but as the industry grows, lots of people come in, there's more competition, profits get squeezed, and the first thing you know is company after company is looking for something they don't need to do and can get it from some high-volume supplier. And that's why you go from vertically integrated into a value net. Think about that now for everything a company does. Insurance company doesn't need to get its actuarial services internally. It can get it over the internet with a set of standards. And that can create new fundamental businesses. So we are in a world that's moving to a world of services. And everything is all about services. We have someone from Google here today. I don't think we have anyone from Microsoft. But why do you think Microsoft is scared of Google? It's not because Google has search, although that's an important thing. It's because Google provides what it provides as a service rather than as something that's a software. And it can provide that in a simple and natural and efficient way. So more and more, our economy in the U.S. and around the world is all about services. And this ain't bad, and some people in the U.S. think that the world is coming to the end because you don't manufacture. But the fact is that you can create huge value by taking this connected world and taking the information that's in that connected world and going up the value hierarchy from data to information to knowledge, wisdom, vision, depending on how you think of that hierarchy. And every step up creates value for the economy. So we've been growing around the world from hardware into services, but that's going to only accelerate because of the connected world. So these predictions about how much services will be in 2050, I think, are completely underestimated. Because every component of what a company does, now because of a set of standards, can be integrated and provided from the outside world. And if you think of Thomas Friedman in The Flat World saying, well, I can outsource what I do in India, that's really not what the main message of that is. The main message is that everything you do, every component of what you do as a company can be broken up into little pieces And each individual piece can be either delivered by a group in India or over the internet as a service. So we're building a services economy. And the R&D, and the reason why R&D has been often viewed as not being very successful because it hasn't been focused on what the value creation is. The value creation is going to be how to work in that value net of companies, not so much the individual hot product. That doesn't mean hot products aren't going to still exist. It doesn't mean that companies aren't going to start out vertically and be very successful. But more and more of the economy, more and more in R&D, is basically tied up with understanding how you can take the pieces of a set of services and integrate them. And that's going to change how universities operate and how R&D laboratories need to operate if they're going to be the value creation, the innovators for the world of the future. Today, there's now over 500 universities that have a program in services science, over 50 in China. Services science is really not so much a science, but it is the engineering of how you put together the pieces of a business. So it's a connection of understanding services and software and, let's say, electrical engineering concepts or computer science concepts together with business concepts. And this is T-shaped people. So that's the basic story. When you put together a world like this, where more and more of the connections are available, and more of the value then is to move up this hierarchy from data to information to knowledge to wisdom, then the economy changes, the value that you create as a corporation changes. And this is what the world of the Internet of Everything is going to be. It's going to be how you can take that everything connected world and all the data that's generated and create value in one way or another by moving up that hierarchy. So I have to finish, I have a few interesting examples. These are Ibm examples about how in an interconnected world you start to see things differently. And you'll hear in the course of this meeting examples that are probably far better than these, some in every industry. So how about everything being connected? Well, lots of examples of companies that are using RFID to make everything pull together. They're everywhere. They're on containers and ships. They can tell you whether the container has been entered. They can monitor whether or not the sensors can monitor what's going on inside the container, including temperature, humidity, other things. They can be used for fleets to optimize how the fleet moves. They can be used in supermarkets. You just see enormous number of opportunities. Not only can you connect everything, but that allows you to have dynamic and very strong rapid responses in the banking industry, in a variety of other areas. And we're not just talking about high-speed trading. We're talking about understanding risk in real time. So there are real-time dynamics that this new world can provide. And as you think about the hierarchy of information, then you see lots of examples where this huge volume of information can generate new business opportunities and optimization. And that can be things like, optimizing really understanding passenger information so you can optimize ticket sales. It can be the kinds of optimization that you see for limousine fleets. And there are huge examples of how you can use the connected world to change and improve in the environment. Everything from better control of traffic. In Silicon Valley, cell phone signals are used for traffic control. People probably don't realize that, if you have a lot of people and all of a sudden their phones are stationary, something's going on the roads. And there's so much interconnected data that you can take advantage of it by optimizing water flow, by optimizing traffic patterns, and all of that can have huge potential environmental advantages. So we are really moving into a fundamentally different environment and fundamentally different world. And the big question for company after company is not so much whether this is going to happen, which it is happening, is what will we do with it as the new revolution continues to come. Thank you very much.
Paul, hang on a second. We have a minute or two for questions now, and then we will have a more open discussion after Neil's conversation. But any questions for Paul at this point? Yeah, Gordon. And please use the microphones, thank you, and identify yourself the first time you speak for the whole group.
So on the landscape of change, which are...
So, Gordon, tell the group who you are, please.
Oh, I'm sorry.
Yeah.
Sorry. My name is Gordon Feller. I'm here from Silicon Valley, one of those cell phone users who's stuck in traffic on a regular basis with Cisco systems. So which of the actors on that stage that you laid out for us are the most resistant to the change, and which are the most adaptive and responsive to the change?
Well, this was an interesting question I had when I talked with the Board of Trustees yesterday. Now that I'm at University, I can tell you the ones that are most resistant to change are universities. Not to shoot ourselves in the foot, but the business model that universities have been using is the same business model that it's used hundreds of years ago. And the cost of delivering that service, as defined by tuition, has gone up at twice the rate of inflation for the last 20 years. And that's not sustainable. So that's a group. And 4 years ago, I actually talked with a bunch of university presidents, and I asked them, how do you think your business model is going to survive? And they all said, don't worry. They said, students don't come here to sit in classes. They come here to go to my campus and to grow up. And parents are willing to pay for that. Well, I would think if you asked that same group of university presidents today, they would be far less sanguine about their existing business model. But it is one that's been very slow to change. It will. It's in the process of it. But it will change from the bottom up.
Which actors are the
most responsive? Oh, that's a good question. And I would also say probably the pharmaceutical industry, for good reasons, is resistant to change. They do far less collaboration because they're still fairly vertically integrated as an industry. Most responsive? Well, I would say the electronic industry in general has been very far along on what Zlowatsky is the guy who, by the way, I should give credit to, wrote the book on profit zones and had this concept of collaborate to compete ratio, and that as industries mature, the collaborate to compete ratio goes up. And you can look at industry after industry and see where are they on that evolution from being vertically integrated to highly collaborative, and then the componentry, software or hardware componentry, comes from the network. The electronics industry is a good example where, if you create a TV, you may not do anything but collaborate and assemble. So that's very far along in the value chain.
All right. Another one for now?